Good morning, everybody. Thank you for joining. So here, can you hear me? Please confirm in the chat box. Good evening, everybody. Thank you for joining. Sunil here. Can you hear me? Please confirm in the chat box. Now. Yes. Thank you. Thank you very much. Fine. Thank you. So what's our agenda for today's session? We are moving on to the next concept of Docker that is called as orchestration. We are moving on to the next concept of Docker that is called as orchestration. Okay. So what is the concept of container orchestration? So first we'll understand what do you mean by orchestration. This is our plan for today's session. We'll understand what is the meaning of term orchestration. And the advantages of orchestrations are nothing but load balancer handling, scaling of containers, performing rolling update and handling failure scenarios. These are all advantages of container orchestration. So we will be practically discussing about these advantages, and then we will learn how can we create the infrastructure for orchestration. So this is our plan for our today's session. So let's move on to understand the concept of orchestration. Okay. Okay. Look at the theory. Please look at the theory. Orchestration is process of running a container in a distributed environment. Orchestration is all about running the containers in a distributed environment. You should understand what I mean by distributed environment. Distributed environment is nothing but running a container on multiple Docker host machines. Running a container on a multiple Docker host machines. As of now, we are creating a container, no doubt. As of now, we know how to create a container, no doubt. We are creating a container on Docker host. We have created a number of containers. All the containers are running on Docker host. On how many host machines you are running the container? Only on one host. Right from the beginning of Docker, we have created one host machine and we are connecting to that particular host and we are creating that containers, removing the containers, we are working with containers. All the containers, whatever we are running, we are creating, we are dealing, all the containers are running on only one host. All the containers are running on one host. What is orchestration? Orchestration is about running a container on multiple host machines. Running a container on multiple host machines. So you will have, let's have a pictorial representation of what even multiple host machines. So you'll have Docker host one more Docker host, 3 Docker host machines. That means 3 EC2 machines. And the container will be created. The container will be running on not one host machine. Container will be created running on multiple host machines. The containers will be created on running on multiple host machines. Now look at the theory. I hope now it will be much more comfortable. The process of running a container on distributed environment, this means on multiple Docker host machines, is orchestration. That's it. As of now, we have never experienced the concept of orchestration. We are creating containers and we are running the containers only on one host. We will be experiencing how can we create containers or run the containers on multiple host machines. Now, when you are dealing with orchestration, you will come across a new term called service. We will come across a new term called service. All these containers will have a single service. Only one service. Containers will have only one service running on them, but they share the resources between each other, even though running on multiple host machines. This concept of running a service, we'll understand it more clearly when we look at the practicals. Okay, so finally, orchestration. If anybody asks you orchestration, your best answer should be running containers on multi-distributed environment. This means running the containers on multiple host machines is called as orchestration. And the orchestration tool is Docker Swarm. Docker is a containerization tool. Docker Swarm is an example of orchestration tool. Docker is different. Docker Swarm is different. Docker Swarm is a tool used for orchestration. So example of container orchestration is Docker Swarm, not Docker. Docker is example of containerization tool. Docker is an example of containerization tool. Docker Swarm is an example of orchestration tool. So Docker Swarm is a tool for use for performing orchestration. What is the advantage you get? What is the advantage you get when you use container orchestration? What is the advantage? What is the advantage you get when you use container orchestration? The advantage is load balancing, scaling of containers, performing rolling updates, handling failure scenarios. These are the advantages of orchestration tool. Load balancing, scaling of containers, performing rolling updates, handling failure scenarios. These are all examples of orchestration. We'll see these examples practically. We'll see this example of what do you mean by load balancing. Okay, what do you mean by scaling of updates? All this we'll see it practically. So I hope you got some information about orchestration. So one final point. Running the containers on multiple host machines, that is called distributed environment, is called as orchestration. We'll practically see how exactly we can take the advantage of orchestration. Okay. The machine on which Docker Swarm is installed is called as manager machine. Now, before introducing you the term called manager and worker. Okay. Before practically showing you, you have to understand about the meaning of the term manager. So whenever you install, till now what we have installed is Docker. We have not installed Docker Swarm. Today we are installing Docker Swarm. The machine in which we install Docker Swarm is called as a manager machine. Okay, let's say I want to run my containers on distributed environment. Distributed environment is nothing but multiple host machines. As you can see, we have 3 host machines. If you install Docker Swarm in one specific machine, that machine is called as a manager machine, and remaining machines are called as worker machines. Remaining machines are called as worker machines. So to experience this practically, the concept of orchestration, we'll be creating 3 machines. To experience the practically concept of orchestration, we'll be creating 3 machines: manager machine, worker 1 machine, worker 2 machine. We'll be creating 3 EC2 machines. Once I create 3 EC2 machines, you'll have clear understanding about the concept of orchestration. So what I'm doing now, I'm creating 3 machines and I name the machine as manager, worker 1, worker 2. Okay. Yes, Wakar, your question. Yes, Wakar, your question, please.
Sir, good evening. Am I audible?
Yeah, you are audible. Please tell.
Sir, we have learned in Jenkins master slave architecture, right? Is it
in
similar?
learning in Jenkins, we have learned master slave
Yes, sir.
configuration. Yes, you are right.
Is it similar or it's different?
In one way, to reduce the load from the master machine, we restrict the jobs to run on the slave machine, isn't it?
Here, I think
That's from the job. That's
master
from the
load.
job. That's from the job point of view to distribute the load. Here also the concept is load only, but here we'll distribute the containers. Something similar. Okay, something similar, but it is entirely different tool. Okay.
Okay. Tool is different, but partially work is similar, right?
Concept is the same. They are also we are performing load balancing. That is with respect to jobs. Here we are performing load balancing with respect to
Here,
containers.
master's work is to
Yes, you are right.
the work to
You are right.
slave, right?
You are right. Something similar to it here also.
Okay. Thank you.
Okay. Okay. So let's practically work out with this concept of orchestration. Yes, sir. Prasad.
Hi, Sunil.
Yep.
My question is like actually Docker is used on ad hoc basis. So like how we are using your Docker form on like load balancing in this.
When yes, your question is very good. When the container is all about infrastructure on demand instantly, isn't it? What could be the reason for, isn't it, Prasad? What could be the reason for load balancing in that kind of cases? What scenarios?
Yes,
Okay.
correct.
So to understand that, you have to wait. First, let's create the infrastructure. Then I'll show you where exactly this kind of orchestrations are used, Prasad.
Okay.
Okay, Prasad. So yeah, let's wait for the environment to be created.
Sure.
Then you will automatically understand the practical usage of this container orchestration. Okay.
Yeah, sure, Sunil. Thank you.
Okay. So what we'll do now, we'll be creating 3 missions. I'll be naming it as manager, worker 1, worker 2. I'll be naming it as so this is what I want to do. Let's go ahead and create it. I already have logged into my AWS account. So I'll be launching instances. How many instances? From the scratch, I'm creating 3 instances. I will go with Ubuntu. I go with Ubuntu 18 version. T2 micro, number of instances. I want to go with the 3 instances. Yes. And I don't want any restrictions, so I allow all traffic from anywhere, and then click on review, click on launch, create a new key pair. I write it as Docker Swarm DS with today's date 3. Download the key pair where I want to download my key pair in my desktop. Sunil folder, I'm downloading my key pair. Scroll down, launch instances, view instances. So I have created 3 instances, as you can see. One instance I name it as manager. Worker 1. Worker 2. Let's wait for the 3 missions to get created. In all the 3 missions, in all the above 3 missions, I'll install Docker in it. I'll install Docker. Okay, that's the first step. Every mission will install Docker. Okay. So you can see all the missions are running. If I want to look at only the running missions, here you can filter by using the keyword called running. If you filter by using keyword called running, you will see only the running instances. I am connecting to my first mission. Click on connect. In my desktop, Sunil folder, I'm opening Git bash. I am connecting to my first mission. Yes. I will be installing Docker. How to install Docker? You already know it. How to install Docker? We already know it. So the site is get.docker.com. Let's wait for the Docker to get installed. Meanwhile, to save time, I will be connecting to second instance. Open one more terminal. I will be connecting to the second instance, that is worker one. So second instance in progress. Meanwhile, I think the first instance is completed. So let's check whether Docker is completed or not. Docker - version. So the first instance Docker is completed. Let's connect to the third instance. Let's connect it to the third instance. In the third instance also, I will install Docker. Meanwhile, I think the second instance is completed. You're right. Docker - version. Yes, you're right. Maheshwara, your question.
It's see, I have a fundamental doubt here. Actually, we are using Git Bash to connect to the AWS terminals, am I right?
Yes.
So, as per in the AWS sections classes, we used to go for convert the
Putty.
PPK into PPK, am I right?
Putty. We are used to connect using Putty.
Putty is instead of that, we can directly use it. Correct? This one.
Which any terminal that does not make a difference. Okay.
Because there we want to
There the additional step we are using puttygen to convert the PEM type to PPK file. So all this stuff are not required when you use Git Bash. Okay.
Okay, but only thing Windows terminal we cannot open using Git Bash. Correct? Actually, only for Linux. Actually,
you are right. You are right. So only for Linux. Okay.
Okay. Okay.
Okay.
So it is both are same, is it? Docker Swarm
Both
and Ansible.
terminals.
Sorry,
No.
Both are orchestration, like Kubernetes and
You are right.
this thing are
Examples
correct,
of orchestration tools are Docker Swarm and Kubernetes. So whatever we are doing on Docker Swarm, we'll also do it on Kubernetes. We will also learn the Kubernetes also. Okay. So we are now first learning Docker Swarm. Later we'll discuss Kubernetes. Okay.
Okay.
Okay. So we are done. We are done installing Docker. in all the 3 machines. We are done installing Docker on the 3 machines. Okay. Now, as there are multiple Docker host machines, when you deal with terminals, by looking at a terminal, it is very difficult for us to check. It is very difficult for us to, the moment you connect any container, let's say I'm connecting to any machine, let's say I'm connecting to manager machine. When you're connecting to manager machine, this is one terminal, you are connected to manager machine. One more terminal you're opening, you're connected to worker one. One more terminal you will open and you're connecting with worker two. Because there are 3 machines, generally we open 3 terminals. By looking at a terminal, it is very difficult to identify, is this terminal pointing to manager machine? Is the terminal pointing to worker one machine? It's very, very difficult. We have to remember the IP address. To make the thing simplified, okay, I change the host name. Host name is nothing but the name of the EC2 machine. I change the host name. The moment you change the host name, here the IP addresses will be replaced with the host name. So here you'll find something like manager. And here you'll find something like worker one. Here you'll find something like worker two. By looking at the terminal, you can easily identify to which machine you're connecting and you're running the commands. Otherwise, it becomes a very confusing task. So what I'll do, this is something optional step. What I'm doing, I'm changing the host name of the EC2 machines. I'm changing the host name of the EC2 machines. Okay. Right now, I'm connected to which EC2 machine ending with 162. Right now, you can see I am connected to IP machine ending with 162. That means I have connected to manager machine. This machine host name, I change it to manager. How to change the host name? Look at this. I have a document. I already have mentioned this. All the 3 machines we have installed Docker. Okay, fine. Now the optional step, what I want to do it. This is something, it's not mandatory. It's an optional step to make yourself comfortable when you're dealing with Docker. So I strongly recommend you to do this additional step. After installing Docker on the manager machine, I want to change the host name. How to change the host name? There's a file called host name under etc directory. So whatever the information you mentioned, whatever the information you mentioned, by default, you'll have the IP address in the particular file. If you change the IP address to a name, that becomes the host name. I want to have the host name as manager. So what I'll do, I go to that particular host name file. I go to that host name file and I go to insert mode. And then here IP, you're getting something like, I change this to manager. So what is the name I'm mentioning in this file? Manager. Escape :WQ to save and quit. I have changed the host name. As now, if you want to change, once the host name is changed, if you want to you have to restart the machine to get that update in the terminal. So I use init 6. Init 6 is a command to restart the EC2 machine. It will be restarted. Similarly, I change the host name of the second EC2 machine. I change the host name of the third EC2 machine. So let's connect to second EC2 machine. I've connected to second EC2 machine. I change the host name to worker one and I restart it. Next, I connect to third EC2 machine. I change the host name to worker two. Restart. Done. I have changed the host name. The advantage what you get when you change the host name is if you connect to the first machine, let's wait. Yes. Anuj Singh, I hope you got the advantage. I hope you got the advantage by changing the host name. By looking at a terminal, you can understand that you are connected to which machine?
Right, Sunil. Manager.
Manager machine. If you connect one more terminal, that will show it as worker one. If you connect to one
Worker.
more terminal, you will show it as worker two. By looking
Worker
at a
two.
terminal, you can clearly understand you are running the commands on which machine. Otherwise,
Right.
it will be very, very difficult. So only for that advantage, I have changed the host name. It's not an optional step, but I recommend you to, when you're dealing with Docker Swarm, please change the host name. So what we have done, Anuj, we have created 3 EC2 machines. We have
And
created
install Docker.
3 EC2 machines, and we have installed Docker. Now 3 are equal machines.
Equal machines.
Okay. The machine in which Docker Swarm is installed, the machine in which Docker Swarm is installed is called as a manager machine. So I will be installing one additional tool in the manager machine that is called as Docker Swarm. Installing Docker Swarm is nothing special. We should run one command. Right now, you can see I already have connected to the manager machine. To this particular terminal, I will be installing Swarm. Swarm is nothing but if you want to install Swarm, it's nothing but one single command. Command to install Docker Swarm in the manager machine. Docker Swarm init. Okay, is the command advertised here? You should mention the private IP address of the manager machine.
Right.
So this is the private IP address of the manager machine. The moment you run this command, Docker Swarm will be initialized. It's nothing but installed in this particular terminal, in this particular machine. As a result of the initializing Docker Swarm, you will generate a token command, a Docker Swarm join token command. This will result in a token command. This token command, you should run it in worker 1 and worker 2. Are you understanding, Anuj? Once you initialize it, Swarm, it generates a token command that is called Docker Swarm join token command. This token command, you have to take a note of it. I'm copying this Docker Swarm join command. This is the Docker Swarm join token command. And this command, where I should run it? I should run it in the worker 1 and
worker 2.
So you can see here, read the log messages, we get the token command. Now we need to add workers to the manager. We have to add, these are worker machines. We have to add these workers to manager. How do you add workers to the manager? By running that particular token command. Okay. So let's connect to worker 1. Can you see? Immediately you can see the terminal happily as worker 1. And here, I copy the token command. Can you see the result of it? This particular node joined the swarm as a worker. Next. Exit.
So we have not converted the key this time to PPK.
That is not required for, that's for putty. We are using git bash, right?
Okay.
For
That is for putty.
not required. Oh, that's only for putty.
Correct.
Worker 2, click on connect. Right now, this terminal is pointing to worker 2. The same token
Worker 2.
command. The same token command I'll be running on worker
Worker
2.
2.
So this particular node has also joined the swarm.
Swarm.
Clear? So total, how many nodes join the swarm?
2.
Total,
One
how many
manager
nodes?
and
One total. How
manager and
many
2 worker.
worker has joined the swarm? Worker 1 has joined the swarm. Worker 2 also joined the swarm.
Swarm.
Okay. So now you can see here. If you want to see number of nodes, Docker node ls. In our distributed environment, now how many nodes we are having? If you want to see the number of nodes, you should always run Docker Swarm related commands in the manager machine only. So because Docker Swarm, I hope you know, because Swarm is installed only on the manager machine. So if you want to see the number of nodes, Docker node ls, very meaningful command. Number of containers, Docker container ls. Number of images, Docker image ls. Number of nodes, Docker node ls. Can you see we have 3 nodes, one manager machine, one worker machine, and worker 1 machine and worker 2 machine. This is your distributed environment. Okay, so you have created a distributed environment infrastructure ready for orchestration. Clear about this? So the machine on which Docker Swarm is installed is called as a manager machine. The moment you install Docker Swarm, it generates a token command. That token command, you run it on worker 1 and worker 2. These 2 workers will join the swarm as a node. So total there will be 3 nodes. Manager itself is also considered as a node. Total will have 3 nodes. That is your distributed environment. Clear, Anuj?
Correct.
Okay, thank you. Yes, Poonam.
Yeah, hi Sunil.
Yep.
This change of host name, it is only possible on the machines on which Docker is installed?
No. It is a Linux concept. Okay, so if you install Docker, if you don't install Docker also, at any point of time, you can change the host name of any Linux machine by changing the host name file. Okay.
Okay.
Yes, Azam. Wakar Azam, your question.
We don't have scope of containers here in Docker Swarm, right?
We don't have
containers concept in Docker Swarm. Container.
No, in Docker Swarm will run the Docker, will initiate the Docker tool so to create the containers. Finally, we need the containers. Okay. Load balancing happens using containers. Okay. So Docker Swarm and Docker goes together here. So you have to wait for the.
When services will be started, that services will be deployed to the container. Right?
Yes, you're right. So if you look at the first example, it will be much more clear for you. Okay, clear about the infrastructure creation, Wakar?
Yes.
We have created manager machine, worker 1 machine, and worker 2 machine. Okay, let's move on. There are 4 advantages of orchestration. As we can see in this theory, I have 4 advantages of orchestration. I'm discussing about the first advantage called load balancing. I'm discussing about the first advantage of load balancing. What do you mean by load balancing? Anuj, can we have a talk?
Yeah, sure, Sunil.
Look at this statement. Each Docker container is designed to withstand specific load.
Right.
If you create a Tomcat container, no doubt it works. But every container is designed to withhold specific load.
Right.
It cannot take unlimited load, isn't it, Anuj?
Correct.
When it's a container, anything, it cannot take an unlimited load. Every container comes with a limited amount of load. Okay?
Right.
When the load increases, the container will crash.
Right.
The container will crash. How do you overcome that problem? By creating a replica containers. Replica is nothing but duplicate. A replica of iWatch. It's a duplicate of iWatch. Replica of iPhone. It's duplicate. By creating a replica containers, and that can be possible using Swarm. And then you can distribute the load. Okay. So this concept is called as, by looking at the name, you can easily understand this concept of load balancing. Let's try to experience the concept of load balancing. The first example is very, very important example to understand the concept. Look at the question first. Start Tomcat in Swarm. Very important. Start Tomcat in Swarm. Okay, not in the Docker host. Start Tomcat in Swarm with how many replicas?
5.
5 replicas. Name it as web server. This is the question. Okay, let's try to understand how can we work out with this scenario. Okay, when you are dealing with Docker Swarm, all the Docker Swarm related commands, you should run it on the
Manager.
manager machine only. You will never run the Docker Swarm related commands in worker 1 or worker 2 because Docker Swarm is not installed in worker 1
installed.
and worker 2.
Right.
The only machine in which Docker Swarm is installed is manager machine. So always when you're running the command related to Docker Swarm, when you want to take the advantages of load balancing, scaling, performing rolling updates, whenever you want to take out that and experience the advantages of container orchestration, you have to no doubt, you have to work with manager machine only. You have to connect and run the commands in the manager machine.
Manager machine.
That's first point. Second point, when you're dealing with Swarm, you will come across a new terminology called service. We'll come across a new terminology called service. Till now, Anuj, we are understanding the terminologies like we are creating containers, we are using images. That's it. Did we create any service? No, we know how to create containers. More than that, we have never discussed anything about that. So we are introducing a new terminology called service. Here, we will never create a container. We will never create a container. We will create a service.
Okay.
First point. Before going to practicals, keep this in mind. My dear friends, we will never create a container. We will create a service. In the service, you will mention how many replicas you want. Here you have to understand the term called. Here you should understand the term called replica. You may have a question, Sunil, what do you mean by replica? Replica is referring to container. If you look at my question, which I just wrote, just read out, I have mentioned that I want to create 5 replicas of Tomcat. That means 5 containers. The term replica refers to container. 5 replicas means 5 containers. 2 replicas means 2 containers. 10 replicas is nothing but 10 containers. We want to create a service with how many replicas? 5 replicas. This is the requirement. This is the requirement.
So service is created in Swarm.
Service is created in Swarm. You're right.
And we define replica in the Swarm itself.
Yes, let's see that first.
Okay.
Look at the command Docker service create. By looking at the command, you can easily understand. Point 1, you're creating a service.
Right.
When you're creating a service, you can provide a name to the service. Like Anuj, when you're creating a container, we are providing a name to the container by using --name C1 or something like that. In the same way, when you're creating a container, you have to provide a name to the container. --name is used to provide a name to the service.
Right.
Service name can be anything. Service name can be S1, S2, S3. Service name can be my name. Service name can be anything. I'm naming a service as web server.
Right.
--name is used to provide a name to the service. I am creating a new service. The name of the service is web server.
Right.
As per the requirement, what you want, what infrastructure you want a Tomcat.
Tomcat.
So this is the name of the image. Whatever you can see in the last word, that's the name of the image.
Right.
--, replicas, as I have mentioned before showing you this practicals, I have mentioned replicas is nothing but a containers. --, replicas, what is the number you are using here, Anuj? 5. That means I'm creating a 5 containers. So if you want to create a container, you have to take use of image. That's why I have mentioned here name of image is Tommy. Using this image, how many containers will be created? 5 containers will be created.
5.
And first point, don't think that 5 independent Tomcat containers will be created. No, that's wrong. It's not 5 independent containers. It's a single service which are using 5 containers. It's only one Tomcat service. Don't be under impression that till now we are creating one Tomcat container. If you create one more Tomcat container, --, name, you create first container as C1. If you write --, name, you can create a second container as C2. But both are independent containers, isn't it, Anuj?
Right.
That is from the Docker point of view, container point of view. Coming to orchestration point of view, you will be creating a service.
Got it.
There will be only one service, one Tomcat service. That particular service uses how many containers? 5 containers.
Right. It's just like a flower with 5 petals.
Something like that. Finally, it's one service.
Right. Got it. So service is
Finally-
one, and that
finally
service
one
beauty is
service.
that it has the beauty of this service is created in Swarm, and we have defined how many replica. This flower should have 5 petals, just like 5 Tommy container.
Yes.
They all are
finally
linked.
It's finally one service.
Correct. Got it.
I repeat the question. I repeat the definition. Docker service create. We are creating a new service. This is the name of the service. I'm naming the service as web server. As mentioned in the definition, I want to create 5 replicas. So hyphen replicas is used to mention how many replicas is nothing but number of containers. When you want to create a containers, obviously you should mention the image. Tomcat runs on the port number 8080, mapping it to 9090 by using hyphen P option. So we are creating one service. Only one Tomcat service. That uses how many containers? 5 containers. That's the concept of service. Let's have an interaction. Yes, Azam. Any questions?
Sir.
No questions?
Yeah. So, services is created on Docker Swarm, right?
Please
I mean,
repeat
on
your
master-
question. I cannot hear you.
So services is created on master node, right?
Not master, manager.
Sorry, manager node. And
Yes, you are right.
That will be distributing containers.
That will be distributed to
worker.
worker 1 and worker 2. How it is distributed, I'll show you the output once we run the command. Okay.
So, sir, here we have mentioned 5 replicas, right?
We have
So
created
if
5 replicas. You are
5
right.
replica. So two replica or 1 replica will master will have.
We'll
one
see.
replica.
We can say practical how exactly the load is
Sir,
distributed.
one question.
Is
I
it
have.
221 or 113 or whatever it is? We'll see it soon.
Okay, sir. One more question I have, sir.
Yes.
Sir, suppose master node goes down, then who will be responsible to take care of?
We'll
these
see it
worker
soon.
nodes?
What happens when the master is down? Master, not master, manager. Okay.
Yeah, sorry, my
Okay. Master is the term we should use it when you're dealing with Kubernetes. Okay.
Okay.
Here, when you're dealing with Swarm, we have to use a term called manager. So manager is down. What happens? We'll see it soon. Okay. Azam. Okay. Please drop your hand once you're done asking your questions. Yes, Maheshwara.
So it is similar to the database concept, read replica, same thing, am I right?
Something similar to it. You're right. Okay. Please drop your hand once you're done asking your questions. Yes. So we have understood that finally we are creating one service. We have understood that command, Docker service create. So let's run this command. When you run this command, what happens? 5 containers with the same service within one individual service, but that particular load gets distributed in how many machines? 3 machines. Load gets distributed in 3 machines. Anuj, when we are talking about load balancing, when you're talking about the advantage of load balancing, finally, when the load increases, finally what the infrastructure needs is more hardware. At the bottom line, you need a hardware. Right. If there is only one Docker host, the complete one Docker host should handle the load. And hardware is limited, so obviously containers go load. But here, what we have 3 individual hardware machines. Agree?
Right.
We have 3 hardware machines. Look at the way how the load gets distributed. Look at this. Always we should run the Docker Swarm related commands in the manager machine. 5 containers will be merged finally to give you one service. Look at the result of this command. The containers are in process of creating and then they get merged to give one service. Please wait. With service converged. How many services we have created? Only one service. What is the name of the service? Web server.
Web server.
This service is having how many containers? 5 containers.
Right.
How the container, where the containers are running? If you want to see where exactly the 5 containers are, do you think all the 5 containers are running on only manager machine? Or do you think 5 containers are working in worker 1 machine? Do you think 5 containers are working on worker 2? No. If you want to see how many containers are running on which particular hardware. Docker service PS followed the service name. What's the name of the service? Web server. Look at the result of this command. You can see here 1, 2, 3, 4, 5 containers are running. Okay.
Right.
Manager machine is taking load of 1 container. Worker 1 is taking load of 2 containers. Worker 2 is taking the load of 2 containers. So 1 plus 2 plus 2. Is the containers distributed?
Yes.
Am I right? The containers are distributed by using a concept called service. By using a concept called service. I'm sorry. So you can see container 1. Here you have 2 containers, you can visualize. So finally load is getting distributed. That means it is using multiple hardwares. And isn't this is called load balancing. This is called load balance. The complete load is not dumped in one particular Docker host. It is using multiple Docker host machines. Finally, it commits one service. Okay. Now you can see we already have discussed manager is taking 1 container, worker on 2 containers, and you cannot control that manager should take 2, worker 1 should take 1. It's not in our control. Finally, you want the containers to be distributed. That's all. Okay. You cannot control which host machine which that is done internally. The software manages it. But you are able to understand that how exactly load is 5 containers with the same service, but the load is distributed to 3 machines. In such case, if I want to, if as it is a service, I want to see the Tomcat page. As the load is distributed to 3 machines, you can take any machine public IP. You have done port mapping 9090, isn't it, Anuj? If you want to experience that particular Tomcat, one service, you can take public IP of the manager 1, you can take the public IP of the manager to worker 1, any WIP. Finally, you will be ending up connecting to that particular service.
Correct.
Okay, so let's take the public IP of manager mission to start with. And port mapping we have used
9090.
9090. Are you able to get the Tomcat service? Let's wait. Yes.
Yes.
Instead of worker manager version, I'll take the public IP of worker 1. Finally, you will be connected to the service. There is no concept of connecting to individual container in orchestration. We will never deal with connecting to individual container. We always deal from the service point of view. You can also take similarly, you can take the IP address of the manager worker 2. It doesn't make any difference. So here you have to understand one more component, which is helping us in the orchestration advantages, that is called as a service. Finally, you end up using one specific service. Clear, Anuj?
Right.
That's how exactly load balancing happens. Okay, let's look at one more example. Start MySQL in Swarm with how many replicas? 3 replicas. 3. That means 3 containers. Like similar to previous example. Docker service create. We are creating a new service. Name can be anything. I'm naming it as MyDB. -- replicas because you want 3 containers.
Right.
When you are using 3 containers, you have to use image MySQL:5.
Right.
This particular image, as you know, it should use environment variable. I'm providing environment variable name. MySQL and providing environment variable. What happens when you do this? One more service gets created. And that service will have how many containers? 3 containers. 3. Copy. This is the second service we are creating. Let's wait for the service to get created.
So Sunil, till it completes. So the service is running on this one, the manager.
Yes, you are right.
So we will be covering, I hope, the manager redundancy, right?
If the manager is down, the same question which you asked by other person, that is called high availability. We'll see it. Okay.
Right.
Service is ready. Now, if you want to see these 3 containers, how exactly the load is distributed, the same command Docker service PS followed with the service name, that is MyDB.
MyDB.
You can see there are 3 containers are running, and worker manager, worker 1, worker 2. Okay, every container is running on individual
Right.
hardware.
Right.
Perfect. This is the advantage of, this is how a load balancing is happening. To perform load balancing only, we are taking the help of containers.
Right.
If the complete load is in one container, then one container cannot be split to multiple hardwares. To split
Correct.
it to multiple hardwares, we are taking help of container concept.
Service.
And the containers can be distributed on multiple host machines. Finally, you are using advantage, you're taking the advantage of multiple hardwares. Clear? Yes.
Correct.
Amsi Krishna, your question.
Yeah, in the previous example, you connected to one of the IP, like 13, like in a worker node, there are 2 servers what I can say,
2 services are running.
2 services are running. Say, if I connected with the IP, to which service it is not connected?
So when you're creating a service, you should make sure that the service should have unique port mapping. Amsi Krishna. Okay?
Yeah.
It should have a unique port mapping when you're creating a service. Like how when you're creating a container, we have performed port mapping, like Jenkins container, Tomcat and error, both are running on 8080, isn't it? So what we have done, make sure that it is running on different port numbers. Here also we should make sure that every service using a different port number, so that we will not have port conflicts. Okay, Vamsi?
Can you minimize this screen? Like
Okay.
I want to save a notepad. Yeah, here if you see like say the second one, 121, 155. So it should have 2 ports, right?
Which should have 2
Worker one
ports.
But in worker 1 there are 2 Tomcat servers are running, right?
One. In
Worker 1, yeah. In worker 1 there are 2 services are running.
which services? Tomcat services.
Tomcat services.
Okay, let's say one service name is 2 Tomcat services. Let's say one service name is S1. One service name is S2. In such case, as both are Tomcat services, we should make sure that they both run on different ports.
Yeah.
One service should run on 9090. Let's say one more service, let's say you can run it on 8080. Or you can run it on 7070. It's up to you, but you should make sure that every service uses a unique port.
Yeah. In this process, we never give 2 different ports, right?
When we will never give
Different port numbers. We give common port number as 9090 for all when creating the service with 5 replicas. Okay, we gave it
when you're creating service 1, the command will be docker service create. Okay. Hyphen name. We will write it as S1 and -P for port mapping. The Tomcat runs on 8080. For the first service, we map it to 9090. Am I right?
Yeah.
Vamsi? Now, when you're creating a second service, as it is also Tomcat, we map it to 7070. So that there will be no conflict issues. And the name of the service will be different.
If we
Okay.
Okay, got it.
Got it, Vamsi? I think now the conflict will be resolved. Am I right, Vamsi? Eh?
But initially what I thought is like as a part of replica, we are distributing the services, right? There itself we can give.
No. I hope now you got the answer.
Yeah. Okay.
Okay. Okay. Next. So you can see here now how many individual services. Now point is how many services are running, not how many containers. The first service what we have discussed is web server. The name of the service is web server. The second service what we have named it as MyDB. So how many services are running on Swarm? Docker service ls, very meaningful commands. Docker container ls, Docker node ls, Docker image ls. If you want to know how many services are running, Docker service ls. How many services are running, Anuj? Two services. One service name is web server, which contains 5 replicas, and one service name is MyDB, which is containing how many replicas? Three replicas. This is the desired state. This is the actual state. Desired state is nothing but after the, as per the definition of the service, when you're creating a service, you have mentioned hyphen replicas 5. This is how many containers are running exactly. We should always orchestration make sure that the actual state is same as desired state. Okay.
Right.
Perfect. Next. So we have discussed about the advantage of load balancing. I also want to discuss about the advantage of handling failure scenarios. Handling failure scenarios. For example, Anuj, there is no concept of Docker Swarm. There is no concept of orchestration. All the containers are running on only one host.
Right.
If because of hardware failure, because of any reason, the host is down, the complete containers will be down. That's it. There's no infrastructure.
Right.
Whereas you can handle that kind of failure scenarios in case of Swarm.
Right.
Look at this.
Even upgrades, reboots.
If you delete a container, if you delete a container, automatically another container will be created, because at every fraction of a second, Docker Swarm makes sure that the actual state should be same as desired state. Because it always makes sure that the actual state is called as same as desired state. For example, I want to see how many containers are running on MyDB. MyDB is having 3 containers because you have mentioned hyphen replicas 3. Three containers are running. 3 containers are running.
Right.
We can see one container is running on the manager machine. You can see one container is running on the manager machine. I want to delete that container which is running on the manager machine. How to see list of containers? Docker container ls. Which will show you list of containers in this particular machine.
Right.
Yes, MySQL container is running and one container is running.
Right.
And that I'm taking a note of the container ID. I have taken note of the container ID and I'm removing from the by force, removing particular container. That's it. Sorry, not this container.
Yeah, you need to copy the upper one. Even Sunil, the same situation happen when one of the worker goes down, right?
Yes,
for example,
yes,
worker
that,
goes
that
down.
is, yeah, that's true. Now one container is removed. As per the service definition, there should be 3 replicas, but we have forcefully removed one container. Now let's see the service, Docker service MyDB, to see list of all the containers specific to one service. As per the definition, there should be 3 services running. Still now there's running, 3 are running. Got it? In one manager machine, we have wantedly removed it. Automatically, before 11 seconds ago, one more container got created, and this is a new container ID. Finally, how many are running? 3 containers are running. Always the desired state is 3. The actual state is also 3.
Right.
At any point of time, the desired state, actual state will be same as desired state. Handling failure scenarios. This is called as handling failure scenarios. Okay. Now, what happens if the complete hardware fails? If the complete hardware fails, I'll come out with that example soon. That's about handling failure scenarios.
One EC2 machine completely goes down.
Automatically, whatever the containers which are running on that particular EC2 machine, that will be shifted to the remaining
other
nodes.
Machine. Remaining nodes.
And again, finally, the desired actual state is same as desired state again.
Right.
Got it?
Correct.
Perfect. So we have discussed 2 advantages. One is load balancing. The other one is handling failure scenarios. Now I also want to discuss about scaling of containers and performing rolling updates. That's not for today's session. That will keep it on Monday session. In Monday's session, we'll discuss about other advantages of scaling of containers and performing rolling updates also.
So scaling means,
Okay.
Sunil, once the load goes off, it
When-
may go beyond 5 or something like that.
When the load increases, we can scale the containers from 5 to 10.
Okay, yeah, that's what
Okay.
I'm waiting for that. Okay, that's why I
okay.
didn't ask.
At runtime without any downtime. Okay. It does not need any downtime. Okay, so there's no point
Correct.
is no downtime. That's the one. That's what cloud wants, isn't it? So the remaining advantages performing rolling updates. You can also upgrade your infrastructure. Let's say from MySQL 5 to MySQL 6 without any downtime. That's called
Right.
rolling updates. These are all advantages of orchestration, which we'll be discussing on Monday
Sunil,
session.
if I
Yeah.
have one Docker host in one specific region and another Docker host in different
It's
region,
not-
maybe
it
different
is-
zone
It is within the region.
within the region,
Okay,
so
the
that they can
infrastructure
they can communicate. They
within
inside the
region.
same
Yeah,
same
you are
VPC.
right. Yes, you are right.
Same.
Finally, it will be fine. We go here.
Same
Good that you are
VPC.
able to relate it to services of AWS. It should
Same
be within the
VPC.
VPC. You are right.
Right.
Because the network communication should happen.
Yep.
Okay. Okay, so I hope you have enjoyed this session of orchestration. The much more concepts of orchestration we'll be discussing on Monday session. And then I want to discuss one more advanced concept related to Docker called as Docker networking. Okay, so those are the upcoming classes for Docker. So have a nice weekend. See you on Monday, where we learn many more the remaining advantages of orchestration. Thank you, everybody. Have a nice weekend and see you on Monday. Bye, everybody. Thank you very much.